Hey everyone, I'm hoping you're enjoying your weekend so far. We're supposed to have some really good weather and I'm spending a lot of time outside. I'm going to make this as quick as possible so I'm not taking away from your weekend, but we're going to look a little bit at biconditionals and definitions. So the first thing you want to know is what a biconditional is. And a biconditional is a single true statement that combines a true conditional and its true converse. So what you're going to do, you're going to be given a conditional and you're going to write its converse and you're going to look to see if both statements are true. If they're true, then you're going to be able to write them as a biconditional. So let's do an example. If the sum of the measures of two angles is 180, then the two angles are supplementary. So that's going to be our conditional. The converse of that would be simply switching your hypothesis and your conclusion. So if two angles are supplementary, then the sum of the two angles is 180 degrees. So if we look at it, the sum of two measures of two angles is 180. So that means they are supplementary. So that is true. So if two angles are supplementary, then they add up to be 180. So that's also true. So I can write this in a biconditional. What happens is I drop the if and then now I replace it with if and only if. So two angles are supplementary if and only if the sum of the measures of the two angles is 180 degrees. So see where I dropped the if and I replaced the then with the if and only if. Okay? Let's look at the next one. Another example. So I'm going to take if two angles have equal measure, then the angles are congruent. The converse of that would be if the angles are congruent, then the two angles have equal measures. So let's look. If two angles have equal measures, then are those angles congruent? That's a true statement. Converse, if the angles are congruent, then the two angles have equal measures. Congruent does mean equal. Since they both are true, I can write them as a biconditional statement. If they're not true, then you can't do anything else with it. So two angles are congruent if and only if the two angles have equal measures. Okay? And then we have something called good definitions, and this is what you're going to be using for you to determine if the converse and the conditional is true. It uses clear, understood terms. These terms should be commonly understood or already defined. It's precise, and it avoids any large words, and it can be reversible. That means you can write a good definition as a true biconditional. And a shorter way to write if and only if statements, so if and only if, you can write it with an if with an extra f. So if you get tired of writing if and only if so many times, just replace it with the IFF. So what I want you to do is I want you to write a biconditional from the following if it is true. So you're going to have to write its converse first and then decide if its conditional is true, its converse is true, then drop your if and replace it then with the if and only if. So I want you to try this right now and come in with your notes on Monday. If you can, comment on the video. If not, not a big deal, but I want you to try the best that you can. And I hope you enjoy your rest of your weekend, and I will see you Monday morning.